Good morning, students. Today is the sixth session of our chapter 3, that is metals and nonmetals. In the last two sessions, we learnt about the extraction process of the metals, which were at the bottom and middle of the activity series. Continuing with the extraction of the metals, today we will see how the extraction of metals, which are at the top of the activity series, is done. I hope you all know what an activity series is. The metals such as potassium, sodium, calcium and aluminium are at top of the activity series. Since these metals are highly reactive, they cannot be obtained from their ores simply by heating or heating with reducing agent. To obtain metals from their ore, in case of these metals, we use the process of electrolytic reduction of their molten chlorides. When electricity is passed through chlorides of metals in molten state, metal is deposited at the cathode and chlorine is liberated at the anode. Here in this slide, let us take example of sodium chloride. When electricity is passed through molten sodium chloride, positive sodium ions gain electrons to form sodium, which deposits at the cathode. Since sodium ions are gaining electron, this is reduction process, whereas reverse happens at the anode, where chloride ions loses electrons to form chlorine gas at the anode. This is oxidation. This can be easily explained by the diagram in the next slide. As you can see in our diagram, we have molten sodium chloride. The battery is connected with two terminals, negative terminal cathode and positive terminal anode. So what happens when electricity is passed through this molten sodium chloride? Positively charged sodium ions of molten NaCl move towards negative terminal cathode and negatively charged chloride ions moves towards positive terminal anode. Sodium ion at cathode gain the electrons released by chloride ions, and sodium metal is deposited at cathode and chloride ions at anode lose electron and chlorine gas is evolved at anode. Okay. Once we have extracted metals or obtained metals from reduction, their refining is done. Refining of metals is removal of impurities from metal to obtain pure metal. The most common method for refining a metal is electrolytic refining. Many metals such as copper, tin, nickel, silver, gold, etc. are refined electrolytically. In the next slide, we will see what electrolytic refining is. Basically, in this method, a thick strip of impure metal is made anode and a thin strip of pure metal is made the cathode. The electrolyte used is salt solution of metal to be purified. For example, in electrolytic refining of copper, a thick strip of impure copper is made the anode and a thin strip of pure copper is made the cathode. The electrolyte is acidified copper sulfate solution. When electric current is passed through the electrolyte, pure copper from the anode is deposited at the cathode and the impurities settle down as anode mud. When electric current is passed, copper ions from the copper sulfate solution are reduced to the copper, which get deposited on the cathode, and equivalent amount of pure copper from the anode gets oxidized to copper ion and goes into solution, and from solution it goes to the cathode and deposit. This cycle is repeated until whole of copper ion from impure rod is dissolved and deposited on cathode. The impurities settle down below anode are called anode mud. Okay student, this completes the extraction of metals in different position in the activity series. We studied extraction of metals which were at the bottom of activity series, metal in the middle of the activity series and metal at the top of the activity series. Go through the chapter in the book also and try to find questions related to these topics from previous year papers. And if you have any difficulty in solving and answering them, you can always contact your teachers. Thank you and have a nice day.